Okay, graphing the inverse functions. So I'm going to be a lot more picky about this once we do a lot with sine and cosine, sine, cosine, and tangent graphs. But here you can work these just with your values. The only thing that switches around here that's a little bit tricky is that your x-axis are your what we usually think about as your outputs, and your y-axis is your angles. So you can do it a couple of different ways. The first way that you could kind of tackle this is to just think about your sine values within that within this range of negative pi over 2 to pi over 2, and make a table for what goes with those. So almost like look at your y-axis. That's where our x's are normally. And either small to big or big to small, what's your angle and what value goes with that angle. So if we're just going to kind of do angle and value in that order, and here, let me write that nicer for you, and bigger. So now our output is our angle and our input is our value. But the angles we're going to work with here for sine are pi over 2 and 0 and negative pi over 2. You can skip over those pi over 4s. So at pi over 2, sine is 1. At 0, sine is 0. And at negative pi over 2, sine is negative 1. And now you have your ordered pairs. So it's not so bad. And I think to make the table, thinking about it backwards is absolutely fine. So negative pi over 2, sine is negative 1. Negative 1, negative pi over 2. 0, 0. 1 pi over 2. This is the only place that this exists. Don't put arrows on the end there. So the domain is negative 1 to 1, including our endpoints, and the range is negative pi over 2 to pi over 2, including those endpoints. Cosine inverse. Again, kind of let your y-axis be your guide here. So I'm going to use 0, pi over 2, and pi. At 0, cosine is 1. At pi over 2, cosine is 0. And at pi, cosine is negative 1. Okay, so negative 1 pi is my ordered pair. This is a really easy one to kind of cross up. See, I just put it in the wrong place. Negative 1 pi. There we go. Negative 1 pi. 0 pi over 2. And 1, 0. Oh my. So our domain here is negative 1 to 1, just like it was with sine. And our range is 0 to pi. Man, I just made that graph is just fun. Oh, there it goes. I just needed to do it backwards. My concavity there was a little bit screwy. All right. Nothing wrong with it taking you a couple tries to get a problem going. All right, for tangent, if you look at your y-axis here, we have negative pi over 2 to pi over 2. The thing about pi over 2 for tangent is that at pi over 2, your tangent value is undefined. So remember, tangent is sine over cosine, and tangent is undefined anywhere that cosine is 0. So when sine is positive 1 and cosine is 0, that happens at pi over 2. So it's going to cause this asymptote here. And we're going to have a horizontal asymptote at pi over 2. The same thing happens at negative pi over 2 because sine is negative and cosine is 0. Sine is negative 1 and cosine is 0. The other value that we're worried about right now is going through 0, 0. At 0, tangent is 0 because sine is 0 and cosine is 1. And then our graph is increasing. The domain and range here, we're going to use parentheses instead of brackets because we're not including our endpoints. So our domain is all reals. This one does have arrows. We are going on forever and ever from the left to the right. Our range is negative pi over 2 to pi over 2. And we're not including our endpoints because of those asymptotes.